So we have been speaking about general, let's say, terms of computer security, and then we're speaking about what is the scope of assets, then classifying those, why do we classify those, then why do we do that? Because they're vulnerable, how to classify vulnerabilities, and then because assets are vulnerable, we have to implement countermeasures, and then how do we classify countermeasures. Now let's speak about network security design principles, a couple of them in general. And the top design principle of a network security, it is going to be not firewalls, not technical, not specific systems, but it's going to be the security policy. Because it doesn't matter what kind of security tools you have in place in order to provide countermeasures against specific attacks. If you don't have a policy which both tells the IT employees how to configure and how to document system changes, so those are trackable. So an admin has to be there has to be a specific policy for each action that somebody takes on a system. Like when you configure, let's say, a firewall rule, there has to be a policy for that. How do you do it? Do you provide a description of the firewall rule? Yes or no? Do you then, after the firewall rule has been configured, do you follow up with the owners of the systems to see if the firewall rule has done its job? Yes or no? Do you watch the firewall logs to see if there's any traffic back and forward with going through that new firewall hole that you open up? Do you follow up to see if users are actually sending appropriate traffic as they should be sending in there? Likewise, on the end system, if you speak about the regular employees, then how can a user behave appropriate if the user has not been trained and instructed on how the user should use the system correctly? Or how can a user know what's allowed and what's not disallowed? Like, for example, how can a user know not to send a specific document out to a friend on the internet if that document, if he was not somehow being told that that document is a classified asset? So if for whatever reason the user got their hands on that document, he may accidentally leak that document out of the company because he was not aware that's a classified document, right? Because a user is not aware of what is important to a company or not. And even if a user should be aware, in network security, we don't assume things. So we just force users and employees to behave in a specific way. We allow them to have access to specific network resources in specific ways. We force the security and the IT employees to configure the devices and monitor them in a specific way, and to document the changes in a specific way. We don't assume they're going to do it because some people are more knowledgeable than other people. Some people are by default, let's say, good people. Other people are bad people. Each of them follows different scopes in there. So that's how we need a common understanding of how to do things and how to behave while in the network, and that's going to be the security policy. Based on the security policy, based on that, in the security policy, actually, you also define the assets. You also define, basically, at the basic level, define the assets, vulnerabilities, optional countermeasures, and then you have attached to the security policies specific documents for specific use cases, for specific assets, and specific countermeasures. It all has to be documented in the security policy. If that's missing, then basically it's chaos. You cannot expect things to work in there. And unfortunately, only large companies are doing this. Most small companies and even medium companies, they just put countermeasures in place, without doing the risk analysis and without doing the network, without implementing a security policy. So as I was saying, we have technical policies, so which means was going to be a guide for employees to properly configure the network, change the network configuration, and adapt the network configuration, monitor the network, log the network, and respond to attacks. And then we have user policies, which are going to guide the users on what are they allowed to do, and how should they use different systems, and for which purposes. There's going to be defense in depth, for example, and the next big concept is defense in depth, which does not mean redundancy, like you're going to go ahead and deploy 3 levels of firewalls, but it means a layered approach. So defense in depth, for example, if you look at the diagram in here, it means that, again, if this is your border network and this is the LAN side, likewise LAN, and this is the internet side, then defense in network, it means that as traffic comes in your network from the internet, so as traffic flows from the internet to your network, and router 4 is your internet gateway, you're going to have a basic level of security on router 4. So a first traffic scrubbing happens on router 4. Then traffic allowed by router 4 is going to be reaching the firewall, which is going to do all kind of inspections, option application inspection, and all kinds of security enforcements to not only allow or disallow the traffic, but also ensure that what the user is trying to send in the network, it's not a malicious traffic. Then as traffic is routed in the network, you may go through a IPS, for example, like instead of router 2, you may have an IPS system, which you're going to speak about as well, which is going to further inspect the traffic for anomalies or for specific attacks. And then as traffic is being further routed to the server, you may have in front of the server what is called a web application firewall, which basically is a very specific firewall aimed to guard against very specific attacks for specific applications. Like if the server is a HTTP server, then that's going to be a web application firewall to defend against the different variations of HTTP based attacks. And then finally, the traffic, if it passes all of the security levels, it reaches the server, where even in there you're going to have a lot of endpoint level security, so some kind of security level deployed at the endpoint. Why is that endpoint security? Because whatever the attacker is sending towards the server, in some cases, only once the server opens the payload of the packet, only at that point can the server assess the impact of the payload on its services. So having other kind of security security tools implemented at the server level, then when the server receives the packet and opens up the payload, those systems on the endpoint can actually identify suspicious behavior or unexpected results as a result of opening that packet, and then they can take action. So this is defense in depth, where you inspect the a session from point A to point B in different places of the network, but with different scopes. So defense in depth doesn't mean that in the transit path of a packet between point A and point B, you end up implementing like 5 layers of firewalls from different vendors, all of them doing the same thing. Layer 3 security, so basic access control, and application security, so application inspection. That's not defense in depth. That's not a concept which is basically called, doesn't have a name. So when you want to deploy multiple layers of security for the same solution, that's not defense in depth. That's optional, and it happens only it happens on a lot of companies, but only for traffic flowing from the internet and only from the firewall point of view. So because most of the attacks are being remotely done from the internet, and because a lot of vendors have their own weaknesses, system weaknesses, and not all vendors let's say achieve the same level of security for the same technologies. Like if you take Cisco's firewall and then Palo Alto's firewall and Fortinet's firewall, each of them are better at specific features that the firewall offers. So that, and each of them has its own vulnerabilities. So in that use case, because most of the attacks are happening from the internet, and because you want to be able to properly inspect traffic coming from the internet, then in that use case you're going to end up deploying in general 2 layers of firewalls from the internet towards your network from different vendors. Like in our use case in here, you're going to end up putting this is going to be level 1 of firewall, which can be Cisco, for example. Level 1 of firewall, which is going to be, let's say, Cisco. And traffic passing that firewall is going to further be inspected by level 2 of firewall. So not a firewall. Level 2 of firewall, which is going to be whatever the company is, XYZ, right? But other than this exception, where you're going to deploy the same technology but for different vendors in your defense in depth strategy, then otherwise defense in depth means providing different level of securities on different locations of the network for different scopes within a packet transit from point A to point B, as we showed before. And then we have what is called network segmentation, which is grouping. This is going to also greatly help if the assets have been properly identified. So network segmentation means grouping assets of same type of value or risk level into security zones. Like for example, in here, if let's say this is a firewall, and this server A data which it's relies on server A is being classified as confidential, and that server is in VLAN 94 as the network segment. So that means that firewall from here has to provide a specific level of security for traffic flowing back and forward from and to that network segment. So that means that you're never going to end up putting in the same network segment another server that holds data which is considered to be public, because it doesn't make sense. Because if the security you implement is done at the firewall level, in here at router 1 at the firewall level, most of the firewalls cannot offer intra-VLAN security. So at that point, you ended up with one asset classified as public and one asset classified as confidential within the same network segment, which means it doesn't make sense to provide the same level of security for both assets. So that's why you're never going to, you should ideally never end up in this design use case of having assets of different value to the company within the same network segment. Because in here you're going to end up either providing the same level of security, which is going to be like for the confidential data, so you spend a lot of resources and money to provide a high level of security to an asset which is classified as public. That's one use case. Or the other use case is you end up providing a lower level of security which is adequate for the public level of assets, which means you leave the confidential data to a higher risk level because you don't provide adequate security measures in there. So either way, you cannot satisfy both requirements. That's why this is not something that should happen in general. That's why you have network segmentation available, which is being done through a lot of methods. You can do layer 3 segmentation via VLANs, and then you can do VLAN segmentation via private VLANs or access lists, or there are a lot of or there are other mechanisms to make sure you also provide intra VLAN security, not only inter VLAN security.